This is your 3.6 WebAssign review. We're using it as your test review for your 3.4 to 3.5 test, or sorry, 3.4 to 3.6 test. Your first question on here asks you to find the X and Y intercepts as well as your asymptotes. We are going to find your X and Y intercept, your vertical and horizontal asymptote, your domain, and any holes. For your X-intercept, or sorry, your given R of X is equal to 5x squared plus 5x over x squared plus 6x plus 5. For your X-intercept, you are going to take your numerator, which is the 5x squared plus 5x, set it equal to 0, and solve for your x. You can factor out the 5x. That's going to leave you with 5x times x plus 1 is equal to 0. Then you set each of those equal to 0, and you solve. For the 5x is equal to 0, divide each side by the 5, and you get that x is equal to 0. For the x plus 1 is equal to 0, subtract your 1 over, and you get that x is equal to negative 1. So these are the two x-intercepts of negative 1, 0, and 0, 0. For your y-intercepts, you are going to plug in 0 anywhere you see an x. So that's going to give you 5 times 0 squared plus 5 times 0 over 0 squared plus 6 times 0 plus 5. This simplifies to be 0 over 5, which is just 0. So your y-intercept is the ordered pair, 0, 0. Next, it asks you to find your vertical and horizontal asymptotes. We're going to start with your vertical asymptote. You're going to take the denominator, set it equal to 0, and solve. So your denominator is that x squared plus 6x plus 5. We set it equal to 0. We factor in order to solve it. You have factors of 5 that add up to be 6 as 1 and 5. So this factors to be x plus 1 times x plus 5 is equal to 0. Set them both equal to 0 and solve. You're going to move your 1 over by subtracting it from each side, so x is equal to negative 1. Move your 5 over by subtracting it from each side, and you have that x is equal to negative 5. So your two vertical asymptotes are x is equal to negative 1 and x is equal to negative 5. For your horizontal asymptote, you are going to compare your numerator's degree with your denominator's degree. The degree for the numerator is 2. The degree for the denominator is 2. These two are equal to one another, so you're going to take the numerator's leading coefficient, put it over the denominator's leading coefficient. That's going to give you 5 over 1, which is just y is equal to 5. When your degrees are not the same, so like if your numerator degree is greater than your denominator degree, it's none. And then when your numerator degree is less than the denominator degree, it's y is equal to 1. Okay. Or sorry, y is equal to 0. Okay. For your domain, you're going to take the denominator, which is that x squared plus 6x plus 5, set it not equal to 0, and then solve it. So we factored this already when we found that vertical asymptote to be x plus 1 times x plus 5. We set both parts not equal to 0, so x plus 1 is not equal to 0, and x plus 5 is not equal to 0. And we solve them by moving the 1 over, so by subtracting it, so x cannot equal negative 1, and then subtract your 5 over, so x cannot equal negative 5. If you have a number line, on that number line, you're going to find that negative 5 and that negative 1. You're going to draw a line that covers every number from negative infinity to positive infinity and erase over that negative 5 and that negative 1. So if you write this using interval notation, you are going to have, or you're going to be going from negative infinity up to negative 5, with a union from negative 5 to negative 1, with a union from negative 1 to infinity. Lastly, you're going to find your wholes. You want to factor the numerator and the denominator and see what would cancel out or what's the same. When we did your x-intercept, you factored the numerator to be 5x times x plus 1. When we did the vertical asymptote and the domain, you factored that denominator to be x plus 1 times x plus 5. The part that is the same on both the top and the bottom is the x plus 1. So you'll take that x plus 1, set it equal to 0, and solve for x. Move your 1 over, subtract it from each side, and you have a whole at x is equal to negative 1. For number 2, we're given the function r of x is equal to x squared plus 4x minus 5 excuse me, over x squared plus x minus 2. We're finding your x and y intercepts, your vertical and horizontal asymptotes, your domain, and your wholes. So same exact thing as the last question. For your x-intercept, you are going to take your numerator, set it equal to 0, and solve. So you have x squared plus 4x minus 5 is equal to 0. Your factors of negative 5 that add up to be 4 are negative 1 and positive 5. So this factors to be x minus 1 times x plus 5 is equal to 0. Set them both equal to 0 and solve them. Move your 1 over, add it to both sides. You get that x is equal to 1. Move your 5 over, subtract it from each side. You get that x is equal to negative 5. So these two are the ordered pairs of negative 5, 0 and 1, 0. For your y-intercept, this is going to change to y is equal to. Your x's are going to become zeros. So you're going to have 0 squared plus 4 times 0 minus 5 over 0 squared plus 0 minus 2. Everything up top cancels out except the negative 5. Everything on the bottom cancels out except the negative 2. A negative over a negative turns into a positive, so you have that y is equal to 5 over 2, which gives you the ordered pair of 0, 5 over 2. For your vertical asymptote, we're going to take that x squared plus x minus 2, set it equal to 0, and solve. Your factors of negative 2 that add up to positive 1 are negative 1 and 2. So this factors to be x minus 1 times x plus 2 is equal to 0. We set both parts equal to 0 and we solve. We move that 1 over by adding it to both sides. We get that x is equal to 1. We move the 2 over by subtracting it from both sides. We get that x is equal to negative 2. So your two vertical asymptotes are at x is equal to negative 2 and at x is equal to 1. For your horizontal asymptotes, we're going to compare your numerator's degree with the denominator's degree. The degree to your numerator is 2. The degree to the denominator is 2. These two 2's are equal to one another, so we're going to take the leading coefficient from the numerator. Hold on. Y is equal to numerator's leading coefficient over the denominator's leading coefficient, which will give us 1 over 1. So that's just y is equal to 1. Next, we're going to find the domain. So we're going to take the denominator, which is the x squared plus x minus 2, set it not equal to 0, and solve. We said when we did the vertical asymptote that this factored to be x minus 1 times x plus 2. So we have that not equal to 0. We're going to set each part equal to 0, so x minus 1 cannot equal 0, x plus 2 cannot equal 0. This is going to give us that x cannot equal 1 and x cannot equal negative 2. So if we were to draw this out on a number line, The only part that our line would not cover from negative infinity to positive infinity would be the -2 and the 1. So to write this in interval notation, you're going from negative infinity up to -2 with a union between -2 and 1 with a union from 1 to positive infinity. From here, the only thing that we have to find that's left are your wholes. You're going to factor the numerator and the denominator. When we did the x-intercept, we factored the numerator to be x minus 1 times x plus 5. When we did the vertical asymptote and the domain, we factored the denominator to be x minus 1 times x plus 2. What's the same on the top and the bottom here? The x minus 1. So take that x minus 1, set it equal to 0, and solve for x. Move your 1 over, add it to both sides, and you have a whole at x is equal to 1. Number 3, we're given the function x squared minus 7x minus 8 over x plus 1. For your x-intercept, you're going to take that x squared minus 7x minus 8, set it equal to 0, and solve. This factors to be x minus 8 times x plus 1 is equal to 0. So if you were to set both of those equal to 0 and solve them, you would get that x is equal to 8 and x is equal to -1. So that gives you the two x-intercepts of -1, 0 and 8, 0. For your y-intercept, you're going to take the numerator over the denominator, put 0 in for any x that you see. So that's going to leave you with -8 over 1. So y is equal to -8. That gives you the ordered pair of 0, -8. Next, you're working with your vertical asymptote. Take your denominator, the x plus 1, set it equal to 0, and solve. When you move that 1 over, you subtract it from each side, so you get that x is equal to -1. So your vertical asymptote is just x is equal to -1. For your horizontal asymptote, you are going to compare your numerator's degree with the denominator's degree. The numerator's degree is 2, your denominator's degree is 1. 2 is larger than 1, so we said when that happens, our horizontal asymptote is none. Next, you are going to find your domain. Take your denominator, that x plus 1, set it not equal to 0, and solve. Move your 1 over by subtracting it, you get that x cannot equal -1. So on your number line, the only number that would not be covered is that -1. So that means that in your interval notation, you're going from negative infinity up to -1 with a union from -1 to positive infinity. Lastly, you want to find your wholes. Factor the top, factor the bottom. When we factored the top, we said that that was x minus 8 times x plus 1. The bottom is just x plus 1. This part that's the same on the top and the bottom is the x plus 1. So we set that equal to 0 and we solve. If we move that 1 over, we get that x is equal to -1. So our whole is at x is equal to -1. For your next one, you have r of x is equal to x cubed minus 3x squared minus 4x over x minus 4. To find your x-intercept, you're going to take the numerator, solve it for x. You have x cubed minus 3x squared minus 4x. You're going to factor out an x. That's going to leave you with x times x squared minus 3x minus 4 is equal to 0. From here, your factors of -4 that add up to be -3 are 1 and -4. So this factors to be x times x plus 1 times x minus 4 is equal to 0. You set them all equal to 0 and you solve. You're going to get that x is equal to 0, x is equal to -1, and x is equal to 4. So this gives you 3 X-intercepts. I know that there's only 2 slots for your X-intercept, but believe it or not, your Y-intercept is the same as that 1 X-intercept of 0, 0. So that's why they like only give you the 2 slots for your X-intercepts and the 1 for your Y-intercept, because your Y-intercept is the same as 1 of your X-intercepts. So when you have the 0, that's going to give you 0, 0. When you have the -1, that's -1, 0. And with the 4, that's 4, 0. To find your Y-intercept, you're still going to have y is equal to 0 over -4. 0 is up top, so that's just y is equal to 0. Remember, we said that if 0 is on top, it's equal to 0. If 0 is on the bottom, it's equal to undefined, so you would not have a y-intercept. Again, that y is equal to 0 is the same thing as 0, 0, which is one of your x-intercepts as well. To find your vertical asymptotes, take your denominator, x minus 4, set it equal to 0, and solve. You get that x is equal to 4. For your horizontal asymptote, you're going to take the numerator's degree, compare it to the denominator's degree. The numerator's is 3, denominator's is 1. 3 is greater than 1, so your horizontal asymptote is none. For your domain, take your denominator, this time set it not equal to 0, and solve. So x cannot equal 4. On your number line, the only number that wouldn't be covered is that 4. So in interval notation, you would go from -infinity up to 4 with a union from 4 to positive infinity. What's your denominator? You take the denominator, set it not equal to 0, and then just solve.
So you can just look at your vertical asymptote and just set that 0.
Yeah. Yeah. It would work the same way. So the question was, if you take the vertical asymptote, can you just set it not equal to that number instead? So instead of it being the x is equal to 4 for your vertical asymptote, for your horizontal asymptote, it would be x is not equal, or sorry, for your domain, it would be x is not equal to 4. And you could, because you're doing the same steps, the only difference is the sign, so the equal sign. For your holes, you are going to factor the numerator and the denominator. We said the numerator factored was x times x plus 1 times x minus 4. The denominator is just x minus 4. So the part that's the same is the x minus 4. You set that equal to 0, and you solve. So x is equal to 4 for your holes. You can't do that with your holes because sometimes that doesn't work out. So for number 5, this one's a little different. It asks you for your slant and your vertical asymptote. If you realize, it doesn't ask you for your horizontal asymptote. So since it doesn't ask you for your horizontal asymptote, you have to keep that in consideration because your slant asymptote can never equal the same thing as your horizontal asymptote. If that is the case, it is none. So you, like I said, keep that in mind while you do this. To find your slant asymptote, you divide the numerator by your denominator using long division. So you are going to have that x minus 8 on the outside of your division house. Then you have the x squared plus 0x plus 0 on the inside. Remember, if you don't have a place value, so to say, for those x to the power of, you have to represent it. That's why we have that 0x and that 0. X times what is x squared? Just x. So x times x is x squared. X times -8 is -8x. We are going to subtract or add the opposites. So those x squareds cancel. 0x plus 8x is 8x. We drop down to 0. Next, x times what is 8x? That's 8. So 8 times x is 8x. 8 times -8 is negative 64. We subtract these or add the opposites. These 8x's cancel, so you just have 64 as your remainder. You do not need your remainder. The only part you need is the part that's up top, which in this case is that x plus 8. You set it equal to y, and that is your slant asymptote. Now, this is a dead giveaway that is actually your slant asymptote because it is a function in slope-intercept form. So it's going to be a slanted line or diagonal line. So you're fine. You really don't need to check it. If you feel like checking it, check it, find your horizontal asymptote. But I guarantee you it's not going to equal your horizontal asymptote specifically because it's not y is equal to 8. It's y is equal to x plus 8. There's an x in there, so you're good. Your vertical asymptote. Find your vertical asymptote by taking your denominator, setting it equal to 0, and solving. Move your 8 over, add it to both sides. You have that x is equal to 8. For number 6, you have r of x is equal to x squared plus 6x over 4x squared minus 9. To find your slant asymptote, you are going to take that 4x squared minus 9, but it's got to be plus 0x minus 9. Put that on the outside. On the inside, you're going to have that x squared plus 6x plus 0. You ask yourself, 4x squared times what is x? That's 1/4. So multiply that by everything that you have on the outside. That gives you x squared plus 1/4 x minus 9 over 4. You subtract these or add the opposites. Those x squareds cancel. That 6x minus 1/4 x is going to be 5 3/4 x plus 9/4. You can't do anything to that x squared to make it an x, so it's just y is equal to the 1/4. Now, is this possible? Do you have an x in that? No, you don't. So if you were to test your horizontal asymptotes, your numerator's degree compared to your denominator's degree would be that 2 is equal to 2. So we would put the leading coefficient of the numerator over the leading coefficient of the denominator and get that y is equal to 1/4. These two are the same, which is not possible, so your slant asymptote is none. For your vertical asymptote, take the denominator, set it equal to 0, and solve. You have 4x squared minus 9 is equal to 0. If you didn't want to factor it and you just wanted to move the 9 over by adding it to both sides, you can do that. You get 4x squared is equal to 9. You would then divide each side by the 4 and get that x squared is equal to 9 over 4. Then just take the square root of both sides. Remember, because you're taking the square root of both sides and the root is even, you got to put that plus or minus in front of your answer. So x is equal to plus or minus 3 over 2. So your vertical asymptote is x is equal to plus or minus 3 over 2. If you wanted to separate that to be x is equal to negative 3 over 2 and x is equal to positive 3 over 2, you can do that too. For our next one, we have r of x is equal to x squared plus 6x plus 5 over x minus 5. To find your slant asymptote, divide the numerator by the denominator using long division. You're going to have that x minus 5 on the outside, the x squared plus 6x plus 5 on the inside. X times what is x squared? X. So x times x is x squared. X times negative 5 is negative 5x. We subtract or add the opposites. So those x squareds cancel. 6x plus 5x is 11x. We drop down that 5. X times what is 11x? It's 11. So 11 times x is 11x. 11 times negative 5 is negative 55. Again, subtract or add the opposites. The 11x's cancel. 5 plus 55 is 60, not 66. 60. That is your remainder, which cancels out. And the only thing you have left is y is equal to x plus 11. that's a slope-intercept form equation or function. So that's your answer. You don't really have to test it with your horizontal asymptote because it's not going to be the same thing. For your vertical asymptote, take your denominator, set it equal to 0, solve it. You get that x is equal to 5. For your next one, it asks you for the slant asymptote and the vertical asymptotes for r of x is equal to 4x plus 4x squared over x squared minus 9. Now, if it was me, the way that I would start this one is I would just rewrite it automatically as 4x squared plus 4x over x squared minus 9. So both my numerator and my denominator are in standard form. When I find my slant asymptote, I'm going to take that denominator, put it on the outside, plug in that 0x to make sure all of my so-called place values are represented. Same thing with that 4x squared plus 4x. I'm going to add a plus 0 to it to make sure all of my so-called place values are represented. I ask myself, x squared times what is 4x squared? That's 4. So I multiply it by everything on the outside. That's 4x squared plus 0x minus 36. We subtract or add the opposites. The 4x squareds cancel. You have 4x plus 36 left over. You cannot do anything to x squared to make it 4x. So you would have y is equal to 4. Is that an equation, slope-intercept form, with an x attached to or in it? No, so your slant asymptote is none.
Do you have to add in zeros if you know you put the 0?
When you do long division, yeah, you have to make sure that you have every place value or like x value represented from the highest power to the lowest.
So if the slant isotope thing doesn't have the x attached, it's none, and then if it matches with the horizontal isotope, it's none.
Right. Yeah. So if you had this y is equal to 4 as a slant asymptote, and you did find your horizontal asymptote, you would have the numerator's degree is equal to the denominator's degree. So you would put the numerator's leading coefficient, which is 4, over the denominator's leading coefficient, which is 1. And it's the same thing as y is equal to 4. So these two are the same. So you don't have a slant asymptote.
How do you know what the horizontal asymptote is?
How do you know what the 4 is what?
The horizontal asymptote.
You check it. Your horizontal asymptote, you compare the degrees to the numerator and the denominator, and then you put the leading coefficient over the numerator over the leading coefficient of the denominator if the one on top is the same as the one on the bottom, degree-wise. Compare your numerator's degree with your denominator's degree. They're the same, so put the leading coefficient of the numerator, which is 4, over the leading coefficient of the denominator, which is 1. Okay. For your vertical asymptote, you're going to take that denominator, which is the x squared minus 9, set it equal to 0, and solve. Move your 9 over, add it to both sides. You get x squared is equal to 9. Then take the square root of both sides, so you get that x is equal to plus or minus 3. Your smaller value is x is equal to negative 3. Your larger is x is equal to 3. So the questions that are added on to this, for number 9, you're writing the polynomial with the given zeros of x is equal to negative 3 halves, x is equal to 4, x is equal to negative 3, and x is equal to 2/5. For this, you have to get everything on the same side as x, so do your inverse operations. If you have fractions, undo the fraction by multiplying the denominator on each side. Then move over the numerator. So set them all equal to 0, then multiply everything out. If we work with the x is equal to negative 3 over 2 first, you're going to multiply each side by the 2. That cancels out the 2 on the left side, so you have 2x is equal to negative 3. You're going to add the 3 over, and that gives you that 2x plus 3 is equal to 0. For the x is equal to 4, you're going to subtract the 4 to move it over, and you get that x minus 4 is equal to 0. For the x minus 3, or sorry, x is equal to negative 3, add your 3 to move it over to be on the same side as x. So x plus 3 is equal to 0. For the x is equal to 2/5, multiply each side by the 5 to get rid of that fraction. You have 5x is equal to 2. Then move the 2 over by subtracting it from each side, and that gives you 5x minus 2 is equal to 0. Now that each of these zeros that are given to you have every term on the same side as the x, and they're equal to 0, set them in a group of parentheses, and then multiply them out. So you're going to have 2x plus 3 times x minus 4 times x plus 3 times 5x minus 2. I'm going to FOIL out the first two and the last two at the same time. So if I FOIL the first two, 2x times x is 2x squared. 2x times negative 4 is negative 4x. 3 times x is 3x. And 3 times negative 4 is negative 12.
Let's go for the 2x times x times -4, isn't it? -8x.
2x, yeah, I don't know why I did the negative 4x. So this is negative 8x. Thank you. Okay. For the x plus 3 times 5x minus 2, the x times 5x is 5x squared. X times negative 2 is negative 2x. 3 times 5x is 15x. 3 times negative 2 is negative 6. We're going to combine like terms first before we do anything else. So, from the first set of parentheses, the 2x squared stays the 2x squared. Negative 8x plus 3x is negative 5x, and that negative 12 stays. From the second set of parentheses, you have 5x squared plus 13x minus 6. From here, we're going to multiply these two trinomials out. So from the first, I'm going to take that 2x squared, distribute it into the second set of parentheses. So 2x squared times 5x squared is 10x to the 4th power. 2x squared times 13x is positive 26x cubed. 2x squared times negative 6 is negative 12x squared. Now I'm going to do the same thing with the negative 5x from the first set of parentheses and distribute it into the second set of parentheses. So negative 5x times 5x squared is negative 25x cubed. Negative 5x times 13x is a negative 65x squared. Negative 5x times negative 6 is a positive 30x. Same thing with the negative 12. I'm going to distribute it into the second set of parentheses. So negative 12 times 5x squared is negative 60x squared. Negative 12 times 13, the 3 times 2 is 6, times 1 is 3. Put your 0 down, that's 2 and 1, so this adds to be 6, 5, and 1. It's going to be negative. So negative 156x, and the negative 12 times negative 6 is a positive 72. We are going to combine our like terms now. So this gives us 10x squared. Your 25x cubed minus 26x cubed minus 25x cubed is just positive x cubed. Your negative 12x squared minus 65x squared minus 60x squared all have the same signs. So we're going to just add them and keep it negative. 5 and 2 is 7. 6 and 6 is 12 plus 1 is 13. So that's negative 137x squared. Then your 30x minus 156x is negative 126x, and that 72 gets dropped down. So you just have the 10x squared plus x cubed minus 137x squared minus 126x plus 72. I keep doing that. So yeah, this is 10x to the 4th power, not squared. 10x to the 4th power. There you go. Okay, so the last question that I've added for you that's similar to ones you're going to see on your test is finding the zeros. If you're given the function f of x is equal to x to the 5th power minus x to the 4th power minus 5x cubed plus 5x squared plus 4x minus 4, You have something that's not 4 terms, so you cannot factor by grouping. It's much larger than that, so you're going to have to use your synthetic division. Find your factors of your constant, which is that -4, and use those numbers to try it with synthetic division to find the one that gives you a 0 as your remainder. Your factors of 4, or -4, are plus or minus 1, plus or minus 2, plus or minus 4. If we try 1, we are going to have the 1 in our box. On the other side, we're going to have 1, -1, -5, +5, +4, and -4. The first term drops down. We multiply 1 times the number in the box, which is 1. Add it with the -1, that gives us 0. 0 times 1 is 0, plus -5 is -5, times 1 is -5. -5 plus 5 is 0, times 1 is 0, plus 4 is 4. 4 times 1 is 4, plus -4 is 0. That gives us the 0 in our remainder that we're looking for, so that 1 is a solution. Now rewrite this 1, -5, and 4 as a polynomial. This 4 is going to be your constant, 0 is going to get your x, the -5 gets your x squared, the next 0 gets x cubed, and the 1 gets an x to the 4th power. So this gives you the polynomial x to the 4th power minus 5x squared plus 4 is equal to 0. Can we factor this? Yeah, you can. You have factors of 4 that add up to be -5. They are -4 and -1. You have to be careful, though, because you have x to the 4th power there. So when you factor this, it's going to give you x squared minus 4 and x squared minus 1 is equal to 0. Can you continue to factor that? They're difference of squares, so you can continue to factor it. That x squared minus 4 is the same thing as x minus 2 times x plus 2. The x squared minus 1 is the same thing as x minus 1 times x plus 1. If we set all 4 of these equal to 0 and solve them, you're going to have x minus 2 is equal to 0, x plus 2 is equal to 0, x minus 1 is equal to 0, and x plus 1 is equal to 0. Solve all of them. Move your 2 over. By adding it, you get x is equal to 2. Move the other 2 over by subtracting it, you get x is equal to -2. Move the 1 over by adding it, you have x is equal to 1. And move the other 1 over by subtracting it, you have x is equal to -1. Look, though, before you think that you're done, look at the original problem. You have x to the 5th power. That's the highest power, so you should have 5 answers. If you just look there, you have 1, 2, 3, 4. Where's your other one? From the synthetic division. You have to include that in your answer. So x is equal to 1 also. So all 5 of those need to be given. If you want to give it as a multiplicity for that 1, you can. You don't have to. You can just write it out like this. If it was me, I would just write it out like this to make sure I have all of my solutions. How'd I get what? Which one? The one that's all the way to the left? From your synthetic division. I include it with my answer. It has to be included with your answer.
I don't know if I believe it, but why the x to the 3rd and the x?
You have zeros on the x to the 3rd and the x. So they cancel out. You don't have them. That's why it's only the x to the 4th power minus 5x squared plus 4 is equal to 0.